Okay, welcome back to part 4 of lecture 2. This is the final part. So once we've completed our simulation, right, this is the completion, then the question is how do we interpret this information, the system statistics, and even from the snapshots, you can start collecting other levels of data, okay? So the first is going to be really from that middle section. We call it customer level performance measures. And you can think of it in this example as part level performance measure. They focus on the details describing the service for the individual entities. So we often call it customers, but you can think of this as entities. So there's a wait time. So there are actually quite a few measures. Really, any kind of measure depends on the system, but there are some fundamental ones that we talk about. The fundamental ones we'll talk about today are waiting time or delay. That's the amount of time that the entity spends in the queue. And then there's time in system. That's the amount of time that entity enters. The total amount, it's also called sojourn time. It's the amount of time from when the arrival occurs to when you finally leave the system. And you see this takes into account the service time. So it takes service time into account. Okay, so if you think about those two sets of numbers, they're actually, because of the randomness that we're going to be assuming occurs in our systems, those are in general also a stochastic process. They're also a random variable. So we need to talk about, if we're going to talk about a single number or kind of a way of thinking about them or measuring them, we're going to think about statistics associated with them. So the common ones that we're going to consider in our reports and for this class are going to be the average or the mean of the random variables, and the minimum and maximum value observed in the experiment. So this is sort of where there is this confluence between random numbers and sort of the probability theory that you've learned in SM239, and then the scientific approach to understanding them, the data analytic approach to understanding them, which is that we're going to run a simulation and then generate data based on our understanding of the underlying probability distributions and try to get a better understanding of these complicated random numbers. And they're complicated random numbers because they don't come from a simple distribution. They're not coming from an exponential distribution. What they're coming from is many different kinds of distributions feeding into the arrival process and the service process, and then the outcome of that. And that's why we have to use simulation, because analytically, it's too complicated to try to calculate. Too is probably a loaded word there. It is complicated to calculate, and it could be intractable. Okay, so here's all that to give you a simple table. This is how we're going to calculate these customer level performance measures. If you think about it, what we need to get for each entity, we're going to need their arrival time, their start of service, their service time, the end of service. And from that, we can calculate times in system and waiting times. And this is going to be the stream of random. You can think of this is the stream of random number realizations for the measures that we're interested in. Okay, so we can populate this with the arrival times. That's just those events that represent, those were the event times that were associated with arrivals. Those should be familiar numbers to you based off the hand calculation. We can get their service time. That was actually just straight from the data itself, right? So we generated these service times in advance of even calculating this. Then we have their start of service. This is sort of the first complicated thing where we actually needed the simulation. If you think about these two columns, these can be directly calculated from just generating the data. Right? The arrival time is just, it's the cumulative sum of the inter-arrival times. The service times are just straight out generated for us. That's that same list. This thing here is the same list that we saw. The start of service, however, is more complicated because remember, it relies not just on when the arrival occurs, but it relies on when the previous entity or the entity in service completes its service, right? So the start of service for entity 2, as you may recall, occurred really after the arrival of entity 4, right? It occurred at 4.63, which if you look at this, is after entity 4 arrived. And that's because the service time here was quite a bit longer than the inter-arrival times for entities 2 through 4. Okay, so that's the start of service. Once you have that start of service, you can actually calculate the end of service, by just adding these two numbers. And of course, this number populates this number. And then again, the sum of this gives you this, which is the same as this, and so on. Okay, and so if you think about this table, you could actually populate it by doing the right sums. And if you think about this table, it's actually what you're constructing with those hand-calculated snapshots, right? The snapshot just keeps it organized for you, but they're the same kind of numbers. Okay, so now we have the data we need to calculate time in system and waiting time. To get time in system, we're going to just subtract end of service, and we're going to subtract out the arrival times. That's the total time in system. Okay, so this whole column is just the difference in the numbers in the end of service column and the arrival time column. Similarly for wait time, the waiting time, we define that as the time that you have to wait before you get to start service. So it's this difference between this column minus your arrival time column. And that's what's going on there. Okay. So now we have the customer level performance measures for each entity. And as I mentioned before, you can think of these as draws off the random distribution, the random number, that is really a function of all these other random numbers and then the system dynamics. Again, a complicated random number. Difficult to understand what that distribution is analytically. In most cases, this is just intractable, actually, to write down. You can't write down a simple formula for it. So that's why we use simulation. We generated a bunch of data, and now we start to get an understanding of this random number. Of course, the first way we start to do that is by looking at summary statistics like average and max. And so we see here the average time in system for a blank part was about 5.5 time units. The average wait time was 2.4 time units. And then the maximum time waited for our system was 9.89 and 5.37 for these first 4 time units. Of course, we want to reduce wait times. Okay, so that's one kind of measure. The other kind of measure we think about are system level measures, and they're measured describing the whole system as a whole. So you can think of customer level. We call it customer because it's sort of this notion of we're serving the entities arriving. System level would be more how do we look at this from a macro standpoint? How is the whole system operating as a whole? Depending on the specific application, you're interested in one or the other. And mostly you're interested in both. So they are focusing on system state and these system statistics. So they're going to include stuff like resource utilization, how long is this queue, how many total customers are in service over a given time horizon. And they're typically going to be time average statistics. Okay, so here are our system level performance measures that we looked at in our hand calculation. We looked at number in system, and we look at the busyness of our server. For each, we need to think about integrating really the area underneath these curves. So all the stuff in blue. So we need integrals, and we're going to divide, because it's going to be time average, we're going to divide that by the time horizon. Okay, so the integration, it's a complicated way of saying area. And of course, these curves, well, we don't really need even calculus to calculate the area under these curves, because these curves are just step functions, which means the area is really just a sum of rectangular areas, right? It's this area, this area, this area, this little skinny rectangular area, this area, this area, and this area, and this area here. Well, this rectangle is even easier. It's really just the length from here to here plus the length from here to here, because remember the other dimension of our rectangle here is 1. And we'll see that's the calculation. So here, this looks like a kind of a mean, nasty sum, but remember this mean, nasty sum isn't that mean or nasty. It's actually just calculating the area of all the different rectangles that I drew before. So it's the sum of areas of rectangles. Okay, and it's divided by 20 because 20 is the time horizon that we were interested in here. Similarly, here, this is just the length. That's this here. Note that the other dimension here is 1, and this fellow here is this length here. Okay, and again, you divide it by 20. And that gives you the utilization rate of 0.694. Note the utilization rate is always going to be a number between 0 and 1. You can think of it as percentage of time or the ratio of time that the server or servers, depending on the application, were busy. That concludes